welcome back to the channel and to the series where we are learning about tree data structure. So in the previous video we learned about basic terminologies related to trees as well as how to implement trees using adjacency list and matrices. So in this video lecture we'll be learning about these traversal techniques. Basically we have a data structure, tree data structure. We want to traverse its nodes, right? So how can we traverse it? That's the problem that we'll be discussing in this video lecture. So let's see how we can do that. So we have a tree structure like this. We have, let's say, nodes here 0 1 2 3 4, something like this. So this is a tree, and let's say I want to perform. So basically there are two traversal techniques. The first one is depth first search traversal, and the second one is breadth first search traversal. So in this video lecture I'll be discussing about the depth first search traversal. And why do we call it depth first? Okay, so let's say I start the traversal, the DFS traversal, from the node number 0, which is the root node. Okay, so let's start DFS from the very first node, which is node number 0, from here, and I visit this node. So since I'm starting from this node, I mark it as visited. So this node is visited, so I print this node. Now this is visited. Now from this node I can move to any of the two nodes. I have two options to move. Either I move to node number 1 or I move to node number 2. Let's say I move to node number 1. Okay, now I again visit this node as well. I visit node number 1, so I print this node. Now again I have two options, either move to 3 or 4. I can move to any of the nodes. Let's say I move to node number 4. So I move to node number 4. Again it is visited, so I print it. Now node number 4 do not have any children, so I can't visit any of the child for node number 4. So I move back. I move back to the parent node, which is node number 1. From node number 1, now I have left child unvisited for node number 1, which is node number 3. So I move to node number 3 here. I visit this node. Okay. Now I have visited all of the nodes in the left subtree for node number 0. So from node number 3, after visiting it, I move back to node number 1. Since all of the nodes and both of the subtrees for node number 1 are visited for node number 1, I move back to the parent node for node number 1, that is node number 0. So the left subtree for node number 1 is for node number 0 is visited. Now I visit the right child, which is node number 2. So node number 2 is visited and I print it. Now node number 2 do not have any child, so I move back. So all of the nodes for the tree has been visited, and this is the depth first search traversal. So you got why do we call it depth first search? Because I started from node number 0, then I visited node number 1, then I visited node number 4. I kept on moving till I reach the deepest level, or the level where I find a node which do not have any child node, or the leaf node, right? So start from the node which has children and keep moving deep down till you do not have any children for the node where you end up. Okay, so you ended up at 4, you moved back to 1, then again you move to node number 3. So in this fashion, the depth first search traversal is defined. So let's take a couple of more examples to understand it better. So let's take one more tree, and then we'll build the intuition towards how we can implement it and prepare the appropriate code for it. So let's take this example. We have a tree like this: 0 1 2 3 4 5 6 7, something like this. Okay, so now here you can see that I start my DFS from node number 0. So DFS is started from node number 0. From node number 0, I move to any of the node. Like I can choose to visit any of the node starting from node number 0. So node number 0 is visited, so I print it. Now let's move to node number 1. So this is visited, move to node number 1. This is also visited. So 1 is also visited. Now node number 1 do not have any right child, so the only option is to move to node number 2. Remember, we are going deep down. I will keep moving on till I find a node which do not have any child. So I found 2, I print it. Move to the child node, which is node number 3, print it. Now this node do not have any child node, so move back to node number 2. Again, this also do not have any right child, so move back to node number 1. Now move back to node number 0. Now from node number 0, move to node number 4. Visit node number 4. From node number 4, I can see I have two options to move. Either move to node number 5 or move to node number 6. So move to node number 5 and print it. From node number 5, move to node number 7 and print it. Now move back to node number 5. Again move to node number 4. And now from node number 4, move to node number 6. Okay, so print the node number 6. Fine. So notice that I started from node number 0 and I kept on moving down till this node number 7, and I printed all of the nodes along the path while moving along this path. So 0 4 5 7. So you can see that 4 5 7 like this 6. Now then I moved back to node number 5, again moved to node number 4, and then traverse the right child, which is node number 6. Then I printed node number 6 here. Fine. So in this fashion I basically traversed this whole tree. Okay, so that's how actually depth first search works, and let's think about how we can implement it. So let's take an example and think about the implementation details. So let's take this tree 0 1 2 3 4 5, something like this. Now start DFS from here. Imagine how this function must look like. Whenever I visit this node, I must remember that this node has been visited so that I do not revisit it again. Why? Because remember in the example, in the previous example, or let's take one more example to understand it better. So let's say we have a tree like this. Okay, so remember that I must not have a cycle, because like you can see that here when I visited this node 4, I must mark it somewhere visited. Why? Because here you can see that if I do not mark my nodes visited, when I come back to node number 4, then again I will have both of the child nodes unvisited, because I am not marking the nodes which I have visited as visited somewhere. So that simply gives me a hint that whenever I visit a node, I must mark this node as visited so that I do not have to revisit the node again. Otherwise, I will end up in an infinite loop, traversing the same nodes again and again. Okay. So let's see how we can do that. To accomplish that task, what I will be doing is I will be using an array of size, let's say size equal to the number of nodes that I have. So the number of nodes that I have here are 6. Okay, so let's use an array of size 6. And initialize it to be 0. 0 represents that all of the nodes are initially unvisited. So whenever I visit a node, so I visit node number 0, I mark it as visited. So I mark node number 0 to be visited. Okay. Now from node number 0, I move to one of the childs. Let's move to node number 1. Let's move to node number, or move to node number 2. Let's move to node number 1. Okay. So let's move here. That means this function must be called again. So I call this function at node number 0, then again the process must repeat. I must print this node, and also I have to mark it as visited in this array. So this function must be recursively called for node number 1 again. So I recursively call this function for node number 1 while marking the child node to be visited. So mark this node 1 as visited and recursively call this. Now again, traverse its child, node number 3 and 5. Traverse node number 3. Again call this function DFS for node number 3 and mark it as visited. So mark node number 3 as visited. Okay. Now from this node number 3, move to like the child node, which is this node number 4. Recursively call this for node number 4 and mark it as visited. Fine. That means mark this node to be visited in this array. So here you can see that I have recursively called this function DFS for all of the nodes 0, 1, 3, 4. From node number 4, move back to, now here you can see that I had to visit other nodes. So I can see that node number 4 do not have any child. So this is a base case. I have to move back to node number 3, which is the parent node. Again, this do not have any right child. So move back to node number 1. This has a right child. That means we have to call the function recursively for the right child as well. So this function call is removed. Again, this is also removed. That means from node number 1, I will recursively call the same function for node number 5. So you're getting where we are going. For every node, I have to visit all of its childs. That also depth wise means first of all for node number 0, I visited node number 1. Then for node number 1, visited 3. Then for 3, visited 4. So I have to visit the entire subtree for node number 0 before I visit the left subtree. And this has to be repeated for every node. For node number 0, then for node number 1 as well. That is, visit all of the nodes in the left subtree, come back, then visit all of the nodes in the right subtree. Fine. So that's the idea. Now call the same function for the left subtree or the root of the left subtree, which is node number 5. So think of it like this. We are treating every subtree as an independent tree. So I started from node number 0. Now I have two options, either move to left subtree or to right subtree. For the left subtree, this is the root node, node number 1. For the right subtree, this is the root node, which is the node number 2. So move to any of these two nodes. I move to node number 1. Now the process will repeat, the same process will repeat, which the same process which I did for node number 0, that will be repeated for node number 1 as well. So that's the idea. The depth first search traversal. From this DFS 5, visit this node number 5, and then from node number 5, come back. So remove this function call, come back to node number 1. From node number 1, move back to node number 0. So remove this function call. Now from node number 0, visit node number 2. Okay, so move to node number 2. So that's the thing. Visit it and also keep marking the nodes for which you are calling the function as visited. So mark this node which is node number 5 as visited. Mark this node which is node number 2 as visited. Okay, so you got it how we are proceeding. Now you can see that this is how the things work. Okay, so again finally the DFS for node number 2, the DFS function call for node number 2 uh, will be popped out from the call stack. So I will go back to node number 0 and that's all. Fine, so you got it. So that's how depth first search traversal is executed. Let's write the code for it. So let me write the pseudo code. So this is DFS function and this takes in a node from where I'm starting the depth first search traversal. From this node, like this node, when I'm visiting this node, I will be marking at visited in the visited array. So in the visited array, mark this node to be visited. So mark this node to be visited. Now this node is visited. Now move to the child nodes for the current node. So move to the child nodes. So traverse over the child nodes. What will be the child nodes for the, let's say we have adjacency list for the current node. That's how we'll be traversing the child nodes. You know how we traverse. We have, let's say, an adjacency list, and for any of the child which is not visited yet, that I will check from the visited array. If this node, which is the child node, is marked as unvisited, then recursively call this function again for the child node. Okay, fine, so you got it how we are doing this. Now for this okay, so that's all. I think that's all we have to do in this DFS. And finally all of the nodes in the visited array will be marked as visited. Okay, so I think that's all. So all of the nodes in the given tree are visited, and finally we have our depth first search strategy implemented here. Now you can see that let's just dry run this code over an example. So let's take an example. Let's take a node which is this one, 0 1 2 3 4. Okay, so let's take this node, and here in this node what I am doing is I am starting my DFS from node number 0. Okay, now I have an array of size which is 5. So array of no size 5, 0 1 2 3, 4. So this is an array of node of 5 nodes. Now from node number 0, mark it as visited. Mark this node as visited and traverse its child nodes. Traverse node number 1 and node number 2. So first traverse node number 1. So mark it as visited. Again, for node number 1, traverse its child nodes, which is node number 3. So traverse node number 3. Mark it as visited. Now for node number 3, traverse its child node, which is node number 4, and again mark it as visited. So all of these nodes are visited. Also, we have a call stack. So initially DFS 0 was there because I called this function. Then DFS 1 is pushed, then DFS 3 is pushed, then DFS 4 is pushed, and so on. So whenever I'm calling the DFS function recursively for the child node, a function call is stacked upon the call stack. Now I move back to node number 3, again back to node number 1, again back to node number 0. Now from node number 0, move to the right child, which is node number 2, and again call this function DFS for node number 5, for node number 2, okay, and mark it as visited. Okay, so again now okay, okay, now I move back to node number 3. I remove this function call. Move back to node number 1. I remove this function call. Move back to node number 0. Remove this function call. From node number 0, move to the right child, which is this one, and that's good. And now recursively call the same function for node number 2 and call this function for node number 2. So mark this node as visited. Fine. So that's how you visit all of the nodes. Now finally, node number 2 do not have any child node, so move back to the root node, which is node number 0. So remove this node, remove this DFS function call. Now from node number 0, again remove the function call for node number 0 as well, because this was also visited. So that's how all of the nodes for the given tree are visited, and that's how we perform depth first search strategy over a given tree when we implement it using adjacency list. Fine, so I hope you got the idea, and let's jump to the code implementation part. Okay, so this is basically the let's just create the DFS function. So void DFS, let's create that function which takes in the node, and let's say the visited array. Here you can see that I will mark this node to be visited and iterate over the child nodes as well. So we have to pass the adjacency list as well. Pass the adjacency list and traverse over the adjacent nodes for the current node. Now if the current node is not visited, then recursively call this function for the child node. Okay, so and pass these functions as well. So here start from the node which is the root node, that is node number 0, and also create a visited array of the same size as as the number of nodes that we have n nodes. We can see that the tree that we have taken has n nodes. Okay, now all of these cells are false because we haven't visited any node yet. So I'm starting from node number 0, and let's okay, so this is basically an adjacency list. So I have to change the implementation first. Adjacency list of n nodes. So adjacency edge 0 dot pushback. Okay, so that's all. Pass in this visited array and the adjacency list, and that's all. This is going to print the nodes. So after you visit this node, you have to print it as well. So see out the current node. This code is going to perform the DFS for the given graph or tree that you have. Fine, so that's all for this video. If you like the video, then hit the like button and make sure to subscribe to the channel, and stay tuned with me for the further updates in the series. I'll be solving a lot of problems on trees, and in the next video we'll learn about breadth first search strategy. And so stay tuned, and I will see you in my next video.